Good afternoon, ladies and gentlemen. Welcome to our presentation today about ModuleWorks Dental Cam. In the next 30 minutes, I would like to present you the innovative features and developments we've done in the last 2 years, including how we have achieved to reduce machining time of chairside indication to less than just 20 minutes. So let's just get started. But first, with introduction about myself and the company. I'm Surush, Product Manager of Dental Component at ModuleWorks. ModuleWorks is a developing CAM software for more than 13 years in the market. It's from Aachen, Germany, which is just 70 kilometers away from here. We have other offices in Romania, Ukraine, as well as additional sales and technical representatives in the UK, US, or recently in Japan. Currently, we are about 140 employees, including the largest development team dedicated just to 5-axis machining. The core products that ModuleWorks develops are 3-axis and 5-axis toolpath generation, as well as simulation engines. These products are provided to other CAD/CAM softwares and integrated into their systems. Similarly, we have dental components, which can get integrated into dental CAD/CAM softwares as well. Let's see how this works in digital dentistry. So here, on this video, we see the well-known workflow of digital dentistry from scanning to manufacturing, where ModuleWorks CAM acts as the interface between nesting and CNC software. It receives the nesting data and performs the toolpath calculations. So you can assume without this CAM engine, the nesting is just a UI which cannot perform the toolpath calculation and runs the CNC machine. Dental Framework is the commercial name for our dental CAM. It is like a plug-and-play dental CAM product, which is integrated into a dental CAD or nesting software. It works like a black box for end user. They just need to call the calculation and will get the manufacturing NC file out of the box. On the background, we receive the CAD data and some of the corresponding construction information. The toolpath calculation and the post-processing are done internally automatically to output the NC file. Dental Framework consists of some main components. The first one is machining templates, verified for manufacturing different kind of indications and materials in form of editable XML scripts. You can see the wide range of indications here, from crown, inlay, abutments, to more challenging ones like denture, implant bridge, bars, and implants. The next component is post-processors, which we have for different kind of CNC machines. The brain of the system is the CAM kernel, which we'll discuss in the next section in details. ModuleWorks Dental Cam. On this slide, I would like to fly over some of the CAM features which we use for different kind of milling and grinding applications, but with some videos. In some cases, we might be a bit fast, but the idea is to give you a general overview about some of the CAM features we use in our software. The first two ones are relatively easy, so it's good for warm-up. Roughing offset. Abutment with angulated screw channels was one of the new indications recently in the market. Here we have a hybrid abutment with a straight and angulated screw channel. And we use offset roughing technique to machine these sort of scenarios. There is another type of roughing that is parallel roughing. What it does is it generates cuts along X or Y axis. Eventually, it forms kind of rectangular pattern on different slices. And we use this technique to rough pre-mill blanks. Geodesic. This is one of our big development which we launched recently. What it does, it generates equidistance toolpaths on any kind of 3D geometries and complexity. Here we can see this abutment with steep and undercut areas, and we can see how the toolpath is kind of homogeneous and equidistant on this complex shape. The feature is available with 4-axis or 5-axis option. And can be implemented in any kind of surfaces. We can see here the steep area of the emergence profile of this abutment. There are some machines like IMS iCore 140, which has just one single slot, and the machine or the part can turn around itself. On these machines, rotary machining is also an option, which can increase the machining time significantly. You can see here the abutment is turning around itself in a rotary fashion, and then we are machining it. So this sort of rotary machining is available for finishing abutments as well. 3 to 5-axis conversion from our constant cost pattern. Actually, here we have just a 3-axis toolpath initially, but once the tool reaches some undercut areas or collisions, it is converted to 5-axis mode to prevent this scenario, the collision scenario, or to project to undercuts. And once it is out of any of these scenarios, it is converted back to 3-axis. So this is a really efficient way of finishing cavities. 3-axis constant cost combined with undercut exclusion. When we apply a 3-axis toolpath here, on the undercut areas, the tool doesn't touch the part and moves basically in the air. Once we activate undercut area exclusion, we trim this kind of waste, because actually these areas will be covered in another dedicated operations. Here we can see all the undercuts with colorful information, and the undercut area exclusion will trim those redundant basically toolpath. And about this undercut machining, we'll talk on the next video. 3+2 axis automatic undercut. Again, we have that picture again, and 3+2 axis automatic undercut finds the undercuts automatically and try to approach them from the best visible machining direction. We can see this implant bridge being machined in 3+2 format from different axes. We also have dentures, which have undercuts from occlusal side, undercuts from the basal side, and then the mutual one. Here we have duplicate of toolpaths processed from both sides. We'll combine these two cycles into one cycle and connect them with this cylindrical transition link. So after machining the first side, the tool will go beyond the blank and the fixture and go to the other side of the blank. This can improve the machining time up to 50% depending on the shape of the geometries. 5-axis constant Z automatic undercut. Actually, this is also an operation just dedicated for undercut machining, but here the difference is that it's fully 5-axis. So as you can see, the tool is tilting and rotating at the same time. Constant cost rest finishing. Detailed and fissure areas of crowns can be machined with constant cost rest finishing tool pattern with in different quality, HD or standard, depending on the tool diameter. This can be used also when cutback feature has been implemented in the design steps. I think rest roughing and excess material at the corners is clear for everybody, which caused this kind of situation where the implant cannot fit. In some interfaces like this, the tool radius has not been designed and considered in the interface design. So we can use corner pegs removal to intentionally over-machine these sharp corners such that the fit with the interface can happen properly. There is another kind of interfaces. We can see the cross-section much better now, where the manufacturing tool radius has been considered in the design. Okay, so here when we have rest materials, we just need to apply rest finishing to remove all those rest materials on sharp corners. You can see it's happening on both sides and also a bit lower on the abutment. There is another type of interfaces as well, which has this complexity on so many different edges and different elevations. Once these critical areas are marked in the CAD data, we can generate a tool path based on our wireframe kernel and force the tool to remove these rest materials on these corners. This feature is available in 2-axis and also 5-axis mode. These were all different features applicable for milling applications. The next series will be for grinding applications. Parallel cutting is an easy approach to grind blanks. Here the trick is basically trimming the tool path against the crown and making the ordering in a way that we create just minimal number of links, and the ordering is still appropriate for grinding machining. This is a good approach for less complex geometries like crowns. For more complex geometries like inlays or bridges, or when users have done a bad pinning, we use adaptive roughing. Adaptive roughing generates these sort of U-shaped cuts on the tight areas and will make sure that it always maintains the cutting load on the tool. So independent of the geometry and complexity of the situation, we can always have a constant load applied on the grinding tool. Constant Z rotary. Again, for machines which have these turning capabilities, a good option to rough the grinding blank is to apply a rotary pattern on it. So here we have a constant Z rotary, but with intelligence adaptive step over, which means here we have relatively larger step overs because the tool is roughing with its shaft. Here we have moderate step overs, and at this area we have more dense step overs because the tool is basically penetrating into material with its tip. This can also reduce the machining time significantly. Spiral helix. Grinding abutment is also another hot topic these days in the for dental communities, and we generate this spiral helix to drill the bore, and we can tilt the till in 4-axis or 5-axis such that we make sure that the coolant can reach end of these bores. So this is a very efficient way of this sort of grinding for making the boards happen, because we can always have the coolant reaching end of the board. Okay, so far here we talked about how we can rough the blank. Now in the second series, we'll talk how we can rough the cavities and finish them. The next two features are not from our latest development, but I will still show them such that we can have a relative comparison. Deep cavities machining via ramps. So here we have a crown which has 4 deep cavities, and we generate these spiral ramps into each of these deep areas, and will converge the will converge these areas together at the end, such that we always make sure we have a machining from bottom to top. Next one is parallel cuts with adaptive depth steps. So here to rough the cavities, we use just a simple parallel cuts, but once the tool reaches the cavity area, we generate these intermediate, basically slices, such that we have a gradual entry into the stock material. This feature and the one before worked relatively stable, especially with bullnose. But the problem with them was that they were not appropriate for chairside market, where we need to be really fast. All of these intermediate slices or those spiral ramps creates a lot of machining time. So what we did to solve this situation was that this constant cuts adaptive step over. This was a really innovative feature for chairside indications, and we could basically reduce the machining time by 50% using this feature. Let's see how this works. The algorithm constantly analyzes the stock. So here we have a crown with these kind of deep shapes again, and the algorithm analyzes the stock in front. So it knows at these areas we are going into deep materials, and it reduces the step over accordingly. We can see these smaller step overs here. Then once it reaches here, it goes back to the normal step overs, and once it is climbing up here, it knows that the amount of stock in front is not significant, and it is doing a swarf machining, so we will have a larger step overs here. This was to rough the cavity. We can use the same technique also for finishing the cavities. On this picture, we can see the cavity has been already machined, but we have rest materials on these small corners, and then here we see the relatively smaller step overs because the full is going into these rest materials areas. Okay, now let's step back, have a glance, and see what all these features mean for the market. This year at the IDS, if you walk around the halls, you will see that there are 2 mutual marketing trends within all scanner, CAD, and CNC suppliers. That is basically labs and chairside. This is the policy we followed on the CAM side as well. And what is happening is on the lab side, they have enhanced the already existing technology. You can see much faster with less hassle scanners, more flexible subscription policies, cool CAD features, capable CNC machines. So what they are trying to do is actually to achieve a massification within labs. On the chairside market, we see very strong intraoral scanners, chair-side CADs, which works just with some clicks, and also nice-looking benchtop grinding machines. So these devices and technologies are emerging to practices. So eventually what will happen is chair-side indications like crown, inlay, abutment, maybe 3-unit bridges will be moved to the chair-side market and will happen there. So what we need here is basically very short machining time and a stable system. This is what we achieved with our innovative algorithms here. On the milling or dental lab side, labs will expose to more challenging jobs like dentures, implant bridges, jobs that you require very strong CAM software with very good 5-axis functionalities. And this is what I just explained. So on the ModuleWorks side, we are really happy to be one of the competing head here and can address the requirements of both market segments. But just to portray what is standing behind these claims, you might remember this puzzle from the ModuleWorks introduction slide. 13 years experience, 140 employees. We are talking about 1,000 man-year code just for CAM applications. And we drive our dental CAM component by this intangible asset. This is the breakdown of the puzzle for our dental component, where we have 3-axis, 5-axis, calculation based on triangular mesh base or wireframe, which I just talked about. So eventually, whatever happens in the market, whether it's a new indications or material or applications, we just pull one of our cards from our kernel side and make it automated in the dental framework and integrate it to the front-end application. We talked enough now about the capabilities of the CAM. Let's just shortly talk about our services and the effort we put to achieve a self-driving automated CAM system, and then we conclude the presentation with this last bit here. Services of ModuleWorks Dental CAM can be classified into different levels. In the pre-sales stage, it consists of accounting and demo, training, marketing, and it can go up to more technical levels, for example, for support or for feature requests, development, analysis, quality assurance, and machining. Or to just keep it short, the packaging of an entire CAM software can be done here in our department. To get a better feeling about this process and what is standing behind these graphs, let's just watch this video, which was captured in our internal dental lab in front of the office, where we facilitate different kind of dental CNC machines there. Our team consists of 7 application engineers with very strong engineering background and also good knowledge about dental market, and they constantly apply different kind of testing. This could be verification of machining templates for different kind of indications and materials for different type of CNC machines, or it could be testing of different algorithms and features after the development within our simulation software. ModuleWorks Dental Partners. These are all different groups of our potential business partners. Naturally, we work much closer to dental CAD and CNC manufacturers, but we support also dental resellers on the background, such that they can promote and brand their products. Dental CAM products, which are powered by ModuleWorks, are ExoCAD, 3Shape, Unique CAD-CAM, Up3D, and Avadent, which started recently working with Dentsply Sirona. Their nesting calls dental framework for toolpath calculations. And these are, for instance, some of the resellers who already committed to distribute one or couple of these systems. To support our partners and resellers such that they can provide a better and easier support for their end users, we also provide some auxiliary tools. One of them is this stock preview, which means after the toolpath calculation, which is relatively fast in case of ModuleWorks Dental Cam, we see the simulated machine stock with colorful information according to a deviation analysis of rest materials. Another one is NC Editor, which is a very easy to use application. We just need to load the NC file into it and click on play to simulate 3-axis or 5-axis machining sequence, either in material removal mode or in toolpath verifier mode. So to summarize, we talked about different competing advantage of ModuleWorks Dental Cam. The verified machining templates and our knowledgeable team, the high-performance CAM software with very strong 5-axis functionalities and different type of features for different applications, post-processors for different CNC machines, as well as these auxiliary tools for better support. So what we believe is that our dental resellers can extend their market share if they decide to use any of these CAM softwares powered by ModuleWorks. They also have the chance to look beyond the only product that they are promoting at the moment and then address different trends and tastes of the market, but all without allocating a lot of resources for the CAM, because all of these well-known CAD/CAM softwares are powered by ModuleWorks Dental Cam. Many thanks for your attention. We understand, hopefully, that there were a lot of content to cover today, but we'll be here at Hall 4.2, stand M30. That is just next to ExoCAD booth. And hopefully we can see some of you guys and go into more technical details with you. Thank you.